All right, let's pull back the curtain on one of the most common and, deceptively simple ways that hackers get their hands on data online. It's an attack called BOLA. And by the time we're done here, you're going to know exactly how it works, why it's so darn dangerous, and even how to spot it. So let's just dive right in. So to get our heads around this, let's start with a really simple idea. Imagine you check into a hotel, right? They give you a key card for your room. Let's say it's room 1001. That card is your proof, your authentication. It says, yep, you're a guest here. But what if you got a little curious and tried that same key card on room 1002? And click, it opens. And then you try 1003, and that one opens too. That little uh-oh feeling in your stomach, that something is very, very wrong here, that's exactly what BOLA is in the digital world. Okay, so let's give it its proper name, Broken Object Level Authorization, or BOLA for short. And this gets us to the single most important idea of this entire explainer, the huge difference between authentication and authorization. Authentication is the server just confirming who you are. Think of the hotel front desk checking your ID and handing you a key. But authorization, that's the server checking what you're allowed to see or do. That's the lock on your specific room door, room 1101, and not any others. BOLA happens when that second check, the important one, is just completely missing. So, how does this actually play out online? Well, it all comes down to how pretty much every modern app and website fetches your personal data. Most of the time, they use a simple, unique number, an ID, to keep track of everything. Now, when you log into an app to, say, check your profile, something like this is happening in the background. Your computer is sending a little message to the server that says, hey, can I please get the data for user number 1001? And because you're logged in as user 1001, the server goes, sure thing, and sends your data right back. Totally normal. So what does the hacker do? This. They just change that last number. That's it. I'm not kidding. No super complex code, no crazy software. They just swap the 1 for a 2. Now they're asking the server for data that belongs to a completely different person. And if that server isn't doing its job and checking for authorization, well, it often just hands it right over. And the fallout is immediate and it's bad. The attacker instantly gets access to someone else's private info, but it gets so much worse. They can start to enumerate all the users, which is just a fancy way of saying they try every number in order, 1002, 1003, 1004, and on, basically downloading the entire user database one profile at a time. This is how massive amounts of data get scraped. Now you're probably thinking, okay, something this simple, it can't be that big of a deal, right? Wrong. According to the Open Web Application Security Project, OWASP we call it, and these guys are the gold standard for web security, BOLA isn't just some risk, it is the #1 most critical security risk for modern APIs. APIs are just the way different computer programs talk to each other. So think about that. Of all the complex, brilliant ways a system can be hacked, this is considered the most dangerous. #1. And believe me, this isn't some theoretical problem you only find in textbooks. This exact vulnerability has been the root cause of some of the biggest data breaches we've seen over the last few years. Just look at Peloton back in 2021. A security researcher found that by making a really simple request to their system, you could pull the private profile data of literally any Peloton user. Their age, their gender, all their workout stats, it was all just sitting there completely exposed because the server never bothered to ask, hey, wait a minute, are you actually this person? Uber had a really similar problem. Attackers figured out they could see the trip details for other riders. We're talking names, pickup and drop-off locations, the whole shebang, just by changing a single trip ID number in the request. It's a perfect and pretty scary example of how sensitive the data exposed by BOLA can be. And seriously, the list just keeps going. This shows you it's not a one-off mistake. T-Mobile has had multiple data breaches because of weak access controls just like this. The social media site Parler had a huge incident where almost all of its data was scraped because of these exact kinds of weaknesses. This is a systemic issue that cuts across all kinds of industries, hitting companies both big and small. Okay, so we've seen the problem, we've seen the damage it can cause. So now let's switch gears. How can you, even as a beginner, start to think like a security researcher and actually spot this vulnerability out in the wild? It's a lot more straightforward than you might think. It really just boils down to 3 simple steps. First, when you're using an app or a website, just keep an eye out for any obvious IDs in the web address or the traffic. Step 2, try changing that ID. Just increment it by 1 or, try a totally random number. And 3, The most important step, watch the response. Do you suddenly see information that doesn't belong to you? If the answer is yes, you've probably just found a BOLA vulnerability. So if it's this easy to find, how in the world do we fix it? How do we build stronger digital locks? Well, thankfully, the logic behind preventing BOLA is just as simple as the attack itself. Let's just look at a bit of code here. On the left, you see the vulnerable logic. The code just gets an order using its ID and sends it back. No questions asked. Now look to the right. The fix is that one extra line of code. After it grabs the order, it asks a simple but incredibly powerful question. Does the user ID attached to this order match the ID of the person who's logged in right now? If the answer is no, access denied. That one little check is the entire solution. Of course, you can and should build even stronger defenses. A great move is to stop using guessable numbered IDs in the first place. For instance, using a generic endpoint like API/user/me always gets the data for the current user, no guesswork needed. It's also absolutely crucial that developers enforce that ownership check on every single part of their application that handles data. And finally, using systems like role-based access control, or RBAC, helps make sure different types of users have different permissions, so a regular customer can't accidentally get their hands on an admin's data. Whew, we've covered a ton of ground, haven't we? From the basic concept to the real-world disasters and, most importantly, the fixes. Now it's time to put it all together and really start thinking like an attacker. So, what are the big things to walk away with? First, and I can't say this enough, authentication is not authorization. Just because a server knows who you are, it doesn't mean it should show you everything. BOLA, in the simplest terms, just means you're logged in, but you can see other people's stuff. It is shockingly common, and the fundamental fix is always check for ownership before you give out any data. And that brings me to my last thought for you. Let's put you in the driver's seat. You're the security tester. You're looking at an app, and you see this exact request flash across your screen. Based on everything we've just talked about, what's your very next move? What are you going to try? Answering that question, that's how you start finding what's hidden in plain sight.